In this recording, we're going to learn how to solve equations involving logarithms. Okay? So the directions here say solve each of the following log equations. We're going to look at 6 equations. Okay? We're going to start with real easy, work our way up to pretty complicated. By first isolating the log, if necessary, and then putting it into exponential form. As we saw with exponential equations, we can solve them by rewriting them in log form. We're going to solve this the opposite way. So let's start with this first example. We're trying to find out log base 6 of what equals 2? Well, let's put it into exponential form. So the equivalent exponential form, let me grab my pen here, rewrite it in exponential form. And you know the exponential form, so write it down. Base is 6. 6. Exponent is what the log is, so 6 squared equals x. Therefore, x equals 36. Well, I could sub that back in and see if log base 6 of 36 equals 2, and it does. All right, let's try the second one. Again, we're stuck in log form, so if we're ever stuck in log form, put it in exponential form. What's the base here? What's the exponent? All right, write it and then play the recording when you've got the exponential form, excuse me. So hopefully you came up with base of 2 to the third equals x plus 5. We know what 2 cubed is. That's an 8. 8 equals x plus 5. Subtract 5 from both sides, and x equals 3. You need to check these types of equations. So if you just sub it back in here, use your calculator, use your head, sub it back in. Okay, so we have log base 2 of 8. What does log base 2 of 8 mean? It means the exponent, right? 2 to the third makes 8. Checks. Let's raise the bar just a little bit here. Okay? Complicated equation here that says 3, then there's log base 5. So that means 3 times, right? If you want, you can put a little dot there. Log base 5 of parentheses, the quantity 4x plus 1 minus 2 equals 4. Well, think of this chunk right here, the chunk that I'm going to identify with a set of parentheses. Think of this chunk right here. I want to get that by itself first. It's kind of like a big 3m minus 2 equals 4. Okay, this m is going to represent this chunk, and you know how to solve for m here. Okay, so write these notes for yourself. Isolate the log expression first by rewriting in exponential form. Excuse me. Isolate the log expression before rewriting in exponential form. I can read my own writing. All right, so what we're going to do first is what we do over here. We add 2. All right, so we got 3 times the log base 5 of 4x plus 1 equals 6. And think about what you would do after you added 2. You would divide. So we'll divide. This is all one term, so we just need to divide over here. So I've got log base 5 of 4x plus 1 equals 2. Well, that got a whole lot easier, right? Now that I've got the log expression isolated, we should be thinking about exponential form. Okay, so this is where we're going to rewrite it into exponential form. It's always the key to solving a log equation if you don't know what the answer is. Put it in exponential form. Okay, and vice versa. So, what's the base here? 5. What's the exponent? That's what the log is equal to. So 5 squared equals 4x plus 1. Easy stuff from here on out, right? 25 on the left side. Okay, take a moment to solve this for x. Okay, so hopefully you subtracted 1 from both sides. You get 24 equals 4x. Divide x equals 6. Okay, we should sub this back in and see if it works. We can check with our calculator. And in fact, it does. Okay, so 4 times 6, 24 plus 1 is 25. Log base 5 of 25. What does that mean? Remember, log is an exponent. So it's saying, what's the exponent you raise 5 to get a 25? That'd be a 2, right? And we multiply the 2 by 3, that's 6. 6 minus 2 is 4. Check. All right, let's raise the bar. This one's crazy. It's got 2 logs in it. Okay? Take a moment to write it down, and as you're doing, make a note to yourself. The first thing we want to do is combine into a single log using properties. Hopefully you got a chance to write this down. Think about what property allows me to combine logs that are being subtracted. Of course, that's the quotient property. You don't need to know the name of it as much as you need to know how to combine these into one log. Okay? This is the positive term, so that's the numerator. This is the negative term, so the x plus 1 is the denominator. Equals 3. Now it's a single log that we've combined it into. We're stuck. Well, no problem. Do what we always do. When you're stuck in log form, exponential form is the key. So, what's the base? What's the exponent? 2 cubed equals the quantity 3x plus 23 all over an x plus 1. So far so good? Still with us? You know 2 cubed, that's 8. Let's put it over 1. Equals 3x plus 23. Now can you solve this proportion? Let's multiply both sides by the x plus 1 to get rid of the fraction. Done. All right. So on the left side, we've got an 8x. I'm going to distribute if it's okay and save a step there. Let's go 8x plus 8 equals 3x plus 23. Okay, so let's just pause and see what the heck we did here. First we saw that there's log written more than one place on the same side. We combined it into a single log using our quotient property. We were stuck in log form, therefore we put it into exponential form. Base to exponent equals the argument. Next, we were stuck in this fraction, this proportion. We got rid of the fraction by multiplying both sides by the denominator x plus 1. Now we're in great shape. Solve this out and write down what your answer is. Okay, so you can bring all your terms to the, let's say, left side. Our x terms are 5x equals 15. It looks like x equals 3. We should check this with our calculator. Use our head. All right. 3 times 3, 9. 9 plus 23, 32. Log base 2 of 32. That's the exponent I raised 2 to get a 32. So that's a 5. All right, so keep that in mind. 5 is all this. Over this, 3 plus 1 is 4. Log base 2 of 4. What does that mean? That means, what exponent do I raise 2 to get a 4? Well, that'd be a 2. Remember, this was a 5 minus a 2 comes out 3. Check. Okay? This one is similar. I see log in more than one place, so I want to combine into a single log using our properties. Logs are being added. So let's go log of x times x minus 3. Okay, we're going to put these together. Equals 1. Multiply the argument. So that means log of x squared minus 3x when I multiply those out equals 1. Where's the base? I don't see it here. Is it okay with you if I write a 10 here? All right, if there's no base, I may write the common log's base of 10 in or not. But you need to know it at this point because I'm going to exponential form and I got to know what the base is. Okay, why don't you see if you can put this into exponential form and solve this one out. Get as far as you can, then play that recording. Right, so if you did 10 to the first power equals x squared minus 3x. Let's solve this, so I'll go 0 equals x squared minus 3x minus 10. Factorable. x minus 5, x plus 2 equals 0. Therefore, according to the zero product property, 0 equals x minus 5. That'll lead me to x equals 5. And 0 equals x plus 2, which leads me to x equals negative 2. I don't know if I made that very clear, but let me erase and try that one more time. X equals negative 2. So, situation like this, we got to think about extraneous roots. If you kind of tuned out, tune in here to see which one of these could potentially be a problem. When I sub in 5, it actually checks. When I sub in negative 2, it does not, because you'd be taking the log of a negative, and that is not real. Okay? So you cannot take the log of a negative 2. So please write this down. This root is extraneous because it would cause us to take the log of a negative, which is not real. Last example. Okay? You've got logs all over the place. Not only do we have logs to combine on the left side into a single log, you've got a log on the right side. Let's do what we did before. We'll combine this into a single log. So we've got log. Now, this is being subtracted. That should mean a fraction to you, right? Log of 2x plus 1 over 3. And the right side is log of 5. Well, hopefully it stands to reason. If the log of this chunk equals the log of this chunk, then those chunks have to be equal. Now, you might say, well, where does the log go? Well, technically, if I raise both sides 10 to the power of both sides, because that's the base of the common log, that is the inverse of log, which gives us just the 2x plus 1 over 3 equals 5. But just thinking about it logically, this chunk, what I'm going to circle here, has got to equal this chunk, because they're the only different things on the either side of the equation. Let's get rid of the exponent multiplying both sides by 3. 2x plus 1 equals 15. Subtract 1 and divide. Seems to me like x equals 7. Okay, and let's make that note over here. If there are logs on both sides, set the arguments equal, the chunks that I alluded to, and then work out. Always checking for extraneous solutions. Thanks for watching. Now try the quiz.